Hello and welcome. In this video, I'm going to teach you all about the migrating motor complex. So what is the migrating motor complex? The migrating motor complex, or the MMC for short, is a motility pattern consisting of cyclic propulsive contractions that spontaneously occur during the fasted state throughout the gastrointestinal tract. It is interrupted by feeding. The MMC is thought of as the housekeeper of the gastrointestinal tract, as it sweeps undigested debris and microbes towards the colon. Theoretically, it is similar to the peristaltic contractions that occur after a meal, which helps to move bolus down the length of the digestive tract. The difference, however, is that the MMC occurs during the fasted state, it has varying contractile frequencies and migrating velocities, and it only occurs along the stomach and small intestine. In order to push debris towards the colon, the MMC initiates contractions of the gastrointestinal smooth muscle. But it's not that simple. One cycle of the MMC consists of three distinct phases. Approximately 2 to 3 hours after a meal, phase 1 begins. Phase 1 is silent with no contractions. It lasts for approximately 90 minutes. Phase 2 lasts approximately 15 minutes and is characterized by random, irregular contractions that can be non migrating or are able to propagate over short distances. Phase 3 is the most critical phase, as the potency of Phase 3 has the strongest effect on the gastrointestinal tract. Phase 3 consists of high amplitude contractions that are able to propagate over long lengths of the gastrointestinal tract. Repetitive contractions occur at different rates and frequencies. In the stomach, high amplitude contractions occur at 3 to 4 per minute, whereas in the duodenum, contractions occur at a rate of 10 to 13 per minute, and in the ileum, about 7 to 8 per minute. The contractions all migrate towards the colon and last longer than 2 minutes. Phase 3 can either begin in the stomach or it can begin in the duodenum. When phase 3 is initiated in the stomach, the MMC cycle duration and length of phase 3 activity are substantially longer. This results in an increase in migration velocity. When phase 3 activity originates in the duodenum, the overall MMC cycle is shorter. Additionally, phase 3 activity is weaker in both contractile frequency and migration velocity. Approximately 70% of the time, phase 3 contractions begin in the stomach, and the other 30% of the time, phase 3 starts in the duodenum. With more back to back cycles, however, fewer phase 3 contractions begin in the stomach, favoring duodenal origin. The significance of the MMC contractile activity is its ability to propel any leftover food debris, as well as microbes, along the GI tract towards the colon. It's been suggested that dysfunctional MMC activity, especially changes to phase 3, is strongly correlated with certain diseases of the digestive tract. This includes conditions such as irritable bowel syndrome, functional dyspepsia, and intestinal pseudoobstruction. Additionally, dysfunctional MMC is also found in other disease states such as obesity, anorexia nervosa, and diabetes mellitus. Interestingly, when phase 3 activity is absent or disordered, bacteria are able to dramatically colonize the duodenum. Pathogenic bacteria damage the mucosal barrier, produce excess gas, and cause nutrient deficiencies in the host. This condition is called small intestinal bacterial overgrowth. What controls the MMC? This is where things get a little complicated. Onset of MMC and mechanistic control of the different phases is regulated by hormones, nerves, and neurotransmitters. Although there are a number of different control mechanisms, I'm going to discuss some of the main players. First, I'm going to discuss motilin. Motilin is a gastrointestinal hormone produced and stored in the small intestine, specifically in the enteroendocrine cells of the duodenum. Studies have shown that motilin fluctuates in parallel with phase 3 gastric contractions, suggesting that motilin is an endogenous physiological regulator of MMC phase 3 gastric contractions. Motilin release is partially regulated by duodenal acidification and bile acids. Number 2 is ghrelin. When exogenous ghrelin is administered in humans, it is capable of inducing phase 3 contractions. Recent studies have found, however, that ghrelin does not fluctuate in parallel with phase 3 gastric contractions as motilin does. Lastly, in order to induce phase 3 contractions, the dose of exogenous ghrelin administered is much higher than what is seen endogenously. Additionally, the vagus nerve plays a role in regulating the MMC as well. In studies comparing the effects to the MMC with and without a vagotomy, it was found that the periodicity of the MMC was affected by the vagotomy, but not the induction of the MMC. Specifically, the vagotomy resulted in a reduction in the duration and amplitude of phase 2 activity. Number 4 is serotonin. Serotonin is a neurotransmitter produced and stored by the enterochromaffin cells in the mucosa of the small intestine. Serotonin was found to stimulate phase 3 activity when administered intravenously, but not when administered exogenously in the duodenal lumen. Serotonin increases the frequency and migration velocity of phase 3. Number 5 is somatostatin. Somatostatin is produced in both the brain and the digestive tract. When secreted by the delta cells of the gastrointestinal tract, it inhibits the release of motilin and therefore prevents phase 3 gastric contractions of the MMC. However, when released, somatostatin induces phase 3 duodenal contractions. Therefore, it has an effect on the origin of phase 3 contractions. So, what do we really know about the MMC? Although the MMC is a fascinating and seemingly critical function of our gastrointestinal tract, there's still a lot that we don't know. I'm going to discuss a few of the things we know for sure and what we still need to uncover in future research. First off, we know that it only occurs during the fasted state, and food interrupts the MMC activity. What we don't know for sure is, do different diets affect activity? I ask this because we know that postprandial motilin is affected by macronutrient composition of a meal, in that high fat meals induce a greater secretion of motilin. Does that affect the MMC activity at all? We also think that stress interrupts the MMC. Although more research is needed in this area to fully understand the mechanistic detail linking stress to disrupted MMC, studies show that acoustic stress applied to dogs interrupted phase 3 contractions completely. Could this be a critical link between stress and impaired digestive function? In one interesting study, it was found that when rats were given short fixed feeding windows, their MMC became regulated, and ghrelin peaked right before the beginning of the feeding window in comparison with the control group. At the beginning of the study, 1/3 of the rats had no phase 3 contractions, and after 2 weeks of fixed feeding, all of the rats had strong predictive phase 3 activity. This begs the question, is intermittent fasting the key to a healthy MMC? Studies have also found that hunger signals correlate with MMC fluctuations, specifically phase 3 of the MMC. Hunger sounds like growling may be a result of phase 3 and may be influenced by motilin. The question then is, should we continue to fast if our stomach is growling? Okay, so here are your 4 takeaways about the MMC. The migrating motor complex is a fasting motility pattern that plays a key role in digestive function. Phase 3 seems to be the most important as it has the greatest capacity to propel debris towards the colon, thereby preventing bacterial overgrowth of the small intestine. 2. Although its physiological role is not completely understood, dysfunctional MMC activity has been implicated in many digestive disorders, including SIBO, IBS, and functional dyspepsia. Number 3, if you want to stimulate your MMC, try fasting. Either try intermittent fasting or space out meals 4 hours apart. Number 4, induction and regulation of the MMC is complicated and multifactorial, as we've seen that it is controlled by hormones, neurotransmitters, and nerves.